Right. Okay. So the rows of the Jacobian matrix are gradients of the corresponding component functions, and that's talked about in this section here. Is kind of sort of kind of how the definition of a gradient is really. What about the columns though? And so if we've got a Jacobian matrix, on the one hand, you can interpret each one of the rows as a gradient of a component function. That was our original observation. And the question is, what about the columns? What do you do here? How do I interpret that? What is that? All right. So the idea is, let's look back to what we were talking about Jacobians in the first place. There it is. So here's our formula for our Jacobian matrix. Well, look at this. There's a formula for the Jacobian. It's sort of where this formula for the Jacobian came from was an observation that we can compute the columns one at a time, and that the columns are partial derivatives of your function with respect to just one input variable. Right. So let me write that down here. These are the partials of the entire, not just individual component functions. This is the partial derivatives of all the components of f with respect to the corresponding input variable there, depending on which column you're in. Okay. So keep in mind f is a function from, well, we've got variables x1 through xn that go out, and then out comes some, f1 through f. M. And the hint says, let me go back to where the hint was. The hint says, if you fix all but one of the values of the input variables, then you can think of it as a parametric curve. And so here's what I mean by that. If you were to take, for example, let's fix all of these variables. Just fix them, right? Then I've got a vector-valued function of what's actually really only one remaining input variable. And so you can interpret this as this becomes a parametric curve. Right? In fact, then, these columns here, so partial of f with respect to x1. What is partial of f with respect to x1? Well, it's exactly this. Partial of f with respect to x1 says fix all these other variables and take the derivative just with respect to x1. In other words, these columns could be interpreted as what you get when you fix all the variables, view this as a parametric curve, and then just take the derivative of that parametric curve. So the columns, this column in the Jacobian matrix you can interpret as the velocity vector of this parametric curve. Where x2 through xn are all fixed. So that's all. Yeah. Does that make sense to everybody? Any questions? Everybody happy? Okay. All right. So in other words, this problem, so there's a little bit of algebra that you're going to write down here, but mostly most of this problem is just kind of about interpreting and discussing. So you're going to have to write up, what I said here in words, you're going to have to write down in like a little paragraph description of what this means, right? But that's the idea.